In this video, I'm going to show you how to connect PN532 directly with your PC without any Arduino microcontroller. In order to use in this way, you must buy one of these controllers. These controllers are called in different names. They're called as FTDI or USB to TTL converters, and they all look either of these. Either you can buy which is red board, or it can be like this way, or everything can be housed like this way. And these boards or converters are not a very expensive, and you can buy them from eBay or the Amazon. I'm going to show you a few examples from the eBay listing. So here is one example. If you go to eBay and type FTDI, you get a listing like this. As you can see here, here the first one has got a cable. Everything is is in one single piece, and the cost phase also, as you can see, they vary from £5, say £3, something like this. Okay. If you search for USB to TTL, you more or less get the same type of listing. So I'm not very sure why it's called FTDI or USB to TTL, but I'm going to explain a little bit on what exactly is this. So this one again, I've chosen one listing in random. As you can see here, this thing is coming with the cable as well, and these cables are the female to female type of cable. And so you have to buy one converter like this if you want to use PN532 without the Arduino. So once you have purchased this converter, you have to connect it. So the way this whole thing works is, from your laptop you connect to this converter, and this converter gets connected to the PN532. So as you can see here, there is no Arduino here, and all the commands must come from the PC. And this is just a kind of a signal converter. It is because, so you have to send the TTL signals to these pins, so which you cannot do directly from a PC, and all your commands coming to this USB converter get translated to probably different electrical voltage levels or current levels. So this is what the overall the connection diagram will look like. So I've got an example here. So the connection is very easy. This is very much similar to the UART connection or HSU connection you saw in the previous video. So as you can see here, so from the PN532 point of view, you have to connect the transmit, the TX line to the RX here, and the RX line of PN532 goes to the TX line here. So this is the most important thing. So as I mentioned here, and other two lines are pretty straightforward. You have to power it. So in this case, the power to PN532, the 5 volts for PN532 come from the PC USB. Some of these converters come with the two different voltage settings, as you can see here. So you got 3.3 as well as the 5 volts. A simple jumper allows you to select either 5 volts or 3.3. In this case, if you have seen the documentation of PN532, you need the 5 volts. So the connection is pretty straightforward. So you just have to make sure that you connect in this way. The main thing using this type of converter is this directly gets connected to your USB, and you will need a wire coming out from this end and connect to the PN532. So first I'm going to show you how I'm going to make a connection like this, and I'm going to show you, I made a small program and show you how this the HSU or a UART connection works. So what you see here is I've connected the USB TTL converter and the PN532, and as you can see here, the connection is pretty straightforward. Make sure the jumper is set to the HSU. That's both switches are set to 00. And once with this connection, the one end of that you're going to connect to the USB. I'm going to show you what happens. So yeah, I've connected to USB, and you can see it's lighted up. So it's very simple. So when you connect this USB to TTL connector, and if you go to this device manager, you can see here this is recognized as a USB device. This is very similar to when you connect the Arduino microcontroller as well. So here what it looks like, this has got CH340 chipset. So what we need from programming point of view is just a USB port, and here it says it is connected to COM3. This is just a little program I've written using Visual Studio and VB.NET. In order to use a PN532 without a microcontroller, it also means we are trying to use this without any libraries. So everything as a developer has to do, you have to send every bit of bytes and commands, and in the later part of this video I'm going to explain how to get this command set and how to understand what's going on between the PN532 and your program. So if I click now on a connect button, I'm trying to make a connection to a port. We know it is in COM3. I have just written programs for very few commands here, almost literally maybe 10% of the commands. So the very first command you have to send to PN532 is called the SAM configuration. So what I've got here is on the top line here, I'm showing you all the bytes. When I say bytes, it is the commands and the data we are sending to PN532. And in the middle row, I'm showing you what I'm getting back from PN532 as a response. And the last row, I'm showing you some process information from what you get from PN532. So the first thing you have to do, and also the documentation says, is you have to send this command called SAM configuration. So this is what your program has to do. So I'm going to explain you a little bit in detail later. So I'm sending all the sequence of bytes. PN532 is sending me this as a response, and I have processed this response. I know what this response is, and I'm saying is okay, it's fine. The next thing is, let us try to run one more command called get firmware version. When we tested PN532 using Arduino, if you remember, the first line of message was version 1.6 and some numbers after that. So let us see what we get when I send this command now. So this is the command I'm sending to PN532, and PN532 is sending me back this response. So when I process this, this is what this response means, and it's very easy to relate these numbers in the response. Say I know that 32 here corresponds to 32 here, and the version is equal to 1 corresponds to the next byte, and the 6 here corresponds to this, and support 7. Okay, so this it's it is for a developer, this is pretty straightforward. Next is, let's see one more command called the general status. So I'm sending something, all these bytes, I'm getting back some responses. I know that this is okay. And the next is the inlist, a command called inlist passive target. Now this is the command used by PN532 to connect the RFID tag. So I'm going to place the MeFair 1K, and I'm going to send this command, and this is the command you have to send, and this is the response I got. Just like the Arduino, the example program did, it used to display the UID of the tag. So this is the UID of this MeFair 1K. Again, as you can see here, this UID is present somewhere here. So right from here, 5844, this is the UID. So like we did in the previous videos, I'm going to scan all the tags we did with MeFair. I'm going to try with ultralight. I'm going to place the tag and send this command again. So probably I didn't get this right. Let's try again. Yeah, sorry. So this is the one, this is the response I got, and this is the UID of this tag. I'm going to try this MeFair 4K, send this command again, and this is the UID of this tag. Let's try the ultralight EV1, send this command again, and this is the UID. Ultralight UID, they have got 7 bytes in the UID starting from 04 up to 80. I'm going to try the ntag 213, send this command again, and this is the UID of that, works fine. Try ntag 216, this is fine. And we know that this red board doesn't recognize or work with the ultralight. See, let's give it a try. Let's see what happens when it didn't recognize. Okay, so this is my programming. I know that there's nothing after this, so no data is present. So let's give it a try a couple of times. Okay, let us try. Next is this the DeskFire EV1. Yeah, so DeskFire EV1. If you noticed here, okay, there are more information for DeskFire EV1. I'm just going to expand a little bit. So it looks like you get more data for DeskFire EV1. Let's give it a try again. Yeah, so there is more information. Yeah, okay. So however, I'm just reading out the UID from this response I got from PN532. So the last command I would like to show you is how to read some data. So I've taken the simplest example, reading the data from ultralight, because ultralight doesn't have any password protection, just you can read anything. There is a separate command to read 16 bytes, so I'm going to use that. So remember, the first thing before you read, we have to first connect. So I'm going to run this command again. So I know it's connected. Let's try to read the read 16 bytes. So this is the 16 bytes, and I know that I have, just before I tested, I've written this message in page number 4. Actually, I'm reading directly from page number 4 and the 16 bytes. So what you have just seen here is, in order to use without a microcontroller, we have to do a lot of coding. So I have just tried these commands. So you have to understand the byte sequence to send, and once you get the response from PN532, to understand how to decode the responses. And there's nothing to be worried about, because all this information you need, it's very well documented by the NXP. So I'm going to show that pretty soon in the later part of this video. This is one more example. I've used a different USB to TTL converter, and the connection is exactly identical to the one we saw before. But keep in mind here, the golden rule is that we follow this simple rule. The TX of FTDI is connected to RX and the RX is connected to TX. So that's exactly what I have done. And just and make sure that you select the voltage to the 5 volts. Here it's a different way, but it's pretty straightforward. Probably now there's a jumper over here to show it is connected to the 5 volts. So I'm going to take I'm going to show you this wiring, and we'll go through the same example. Probably I'll be showing that quickly because it's the same thing. So here it is again. I've connected to the same PN532 board, and this is how the connection is. And probably when you buy this from internet, make sure you also buy this mini USB. This is this cable is pretty, I think you have to pay £1 to buy them separately. If you get the board and the cable, you can look for the best price. So you have to first connect this. So I've connected that, and the other end I'm going to connect to my PC now. Yeah, so both are fired up, and let's see how this thing works. Now if you go to the device manager and look into this ports and USB, you can see this converter is recognized as a USB serial port, whereas before it was something like a CH340. So it doesn't matter for a developer. So we just need a serial port with the COM number, what it says here, COM5. This so back to this program again. I'm going to click on the connect. This time you can see it's a COM5. Let us first do the SAM configuration. That's fine. The get version, it's the exact same thing. So status is also fine. So let's try this card 1K. This also works fine. And ultralight, that's fine. This is the desk 5, it's fine as well. Try ultralight C. That's also, it worked in the sense it didn't recognize any card. 216. Oh sorry, I clicked the wrong button. But this could be something wrong with my program. I think the best thing is just disconnect and try again. Yeah, try the SAM configuration, and I can directly go to list. That's fine, works alright. The 213, this works fine. Ultralight EV1, that's okay. And the 4K, that's fine as well. And let's try the last one, reading the page number 4 from the ultralight. So that is my programming error, not error, sorry, probably didn't read properly. So I should have given this in select and read 16. Okay, that's fine. So we just saw that this USB or TTL connector also works. And let's see what I've got next for you. So let's say I'm going to connect. It connects to COM5 and SAM configuration. We got the result. Firmware, we got the result. This is the same version as well. And general status. And let's try quickly all our tags. Try this in random. So I'm going to try EV1. It works all right. The ultralight works fine. The NTAG 213 works fine. NTAG 216 works fine. The DESFire works fine. The MeFire 1K fine as well. And we know that this whiteboard works with the ultralight C. Let's give it a try. This works fine as well. And the MeFire 4K works alright. Let's give it a try for reading the data, the 16 bytes of data from page number 4 of ultralight. And you have to first connect, then try reading this 16 bytes. That's fine. So even the whiteboard works with the directly with the PC. In the next example, I'm going to show you a different way of connecting to this PN532 whiteboard and the converter, and this is called as the FTDI, the cable connection. So on these bigger boards, or even in smaller boards as well, if you come across this FTDI pins, so there's a small trick here. So instead of, if you look at this table, you have to connect the TX of FTDI to the TX of this the TX of PN532 goes through TX of FTDI, and RX goes to RX. It's completely a reverse of what we did in the previous connection. So keep in mind, if you connect this over here, you'll have a reverse TX to RX and RX to TX. Whereas if you connect to here, so you'll end up having the like ports, TX to TX and RX to RX. And I've also seen, if you trace out the connection here internally, you will see that I've just shown that in a red marking here. The TX of this pin is internally connected to RX here, and the RX of this connects to TX here. So you can also buy a FTDI cable which comes with a group of connector that directly fits into this FTDI connection. Okay, so just keep in mind, so you have a connection the way I've shown here. So I'm going to show you this, and we're going to run the same program again. So you can see here I've got the cables now are connected to FTDI, and the connection is the way what I've shown in the slide. So let's go and try. So I'm going to connect to COM5 and try the first few commands. Get version. It's working here. So this proves that connecting TX to TX and RX to RX works. Let's try detecting, and I'm going to read this as well. Okay. So that's it. And I also got the next video where I'll be discussing how these commands work, and I'm just going to cover in brief understanding the manual that comes with the PN532. So if you're not a developer, or if you don't understand all these bytes and commands and response, probably you can skip the next videos and go to my later videos. In this example, I'll be showing you how to make connection with the blue board we have been using in the previous videos. The connections are identical to the other boards. Just have to keep in mind the golden rule, this RX and TX. So RX of PN532 goes to the TX, and the TX goes to RX. Otherwise everything is the same. And keep in mind, this board doesn't come with a switch, and you have to desolder it. So as well, this board also comes with the FTDI connection, because when you buy this board, they usually don't come with the pin soldered. So you get around 8 or 10 pins. So you have to solder. If you want to use FTDI cable connection, you have to solder this bit. So I'm going to show you how to use this board, and quickly with all our example tags as well. So this is the connection I have got, and we have seen this before as well. It's pretty straightforward, and as you can see, I just need 4 wires to do these connections. So I'm going to connect and use the SAM setting. It works all right. Get firmware, get status, and let's quickly try the NTAG 203. This is fine, and try all the tags. We know this board works with all the tags I've got. Oh, sorry, I have to first select it, then give the read as well. So that's fine. So just go through all of the tags, working all right. It's the EV1, works all right. So we know this board works with ultralight C as well. That's fine. This is the 1K. This is the DESFAR. All right. NTAG 216. All right. And the 213. That's fine. So probably now, if you follow these instructions, you can connect any PN532 board with any make of FTDI or USB to TTL connection. Just follow the golden rule, the TX and RX and RX and TX.